Hello there, my name is Benjamin Wasserstein, and I'm here today to talk to you about SafeSoftware's spatial ETL tools via their FME platform. Now I'm excited to get started. We have a lot to talk about today, so let's jump in. So what is FME? FME stands for the Feature Manipulation Engine, and this is the platform that Safe's spatial ETL tools run on. Now, in short, the ETL tools will connect your applications, transform data, and automate workflows just as any other ETL tool set would. But there's this spatial aspect to the data, and spatial aspect or geospatial aspect. We're talking about GIS, CAD, LiDAR, GPS, BIM, XML, Oracle Spatial, all of these different spatial file types where the data sits somewhere spatially. It's located somewhere. When we're talking about the geospatial aspect of data, we're talking about where that data sits on the planet. So for that data to sit somewhere, it needs to match the curvature of Earth, so it needs to be given some projections. And Safe's spatial ETL tools allow for you to move between 5,000 different projections. And once we integrate spatial data with non-spatial data, we really open up a world analytical opportunities, and that's why Safe's product is so popular. It's been integrated into these different technologies, ArcGIS, Tableau, SQL Server, but it's popular among an incredible list of industries, anywhere from emergency, policing, research, education, architecture, infrastructure, construction, the list goes on. And when we look at the organizations using FME, BLM, Australian Government and Wildlife Service, Shell, cities, states, local governments around the world, oil and gas companies, telecom companies, Park Service, U.S. Census Bureau, Natural Resources Canada, UN Environmental Program, Esri. You can go on Safe's website and read stories from all these different organizations about how they're using FME. Today, my demos will be looking at how FME is integrated into Esri, and we'll be accessing the FME workspace through Esri. But I just wanted to point out here that Esri's chosen SafeSoftware because they've really set the standard for spatial data interoperability. But before we get started with any demos, let's just talk about Safe for a bit. So who are they? Now, I've never heard of them. Well, they coined the term spatial ETL in 1993, and back then they were working to help forestry companies exchange maps with the provincial government of Canada. So they found that they were losing a lot of data in between, and they built FME to streamline the process and to eliminate data loss. They're based out of Canada, and just to give you a show of how robust their program is, they support read and write capabilities to over 400 different file formats. And they have a transformer gallery with hundreds of transformers. And this is the transformer gallery is comparable to Microsoft's Integration Studio's toolbox. And all of this is the reason why 20,000 plus organizations are using SafeSoftware and their FME platform. Now, before we jump into any demos, I just want to give you some basic components and definitions of the FME workspace. So we have a reader, and this is what will read data from the source file. This is the extract component to ETL. We have a transformer, and this is an item that can be dropped in the workspace to perform translations, restructuring, and integration that's needed. This is the transform aspect of ETL. And you can create your own transformer or suggest your own on Safe's website. I'd also like to point out that they have caller transformers. So there's just the Python caller, the R caller, inline querier, which I use a lot, and this allows you to harness code within FME. Alternatively, for example, with Python, you can integrate FME into a Python script. So you can run Python both in FME, or you can have a Python script called to FME. And then lastly, we have a writer, which writes to the destination file. This is the load aspect of ETL. So we're going to jump into some demos really quickly here, and I'll show you what we're doing. So I have a bunch of spatial tabular data, essentially an Excel file with coordinates that came from my GPS receiver. And these have an object ID field, which I can relate to my notes, which I all digitized from my notebook. And these are essentially just, animals that I saw near my house. So this is, I have the spatial data and I have my notes, and I want to join these up and display them on a map. So what I'll do is I'll create a new toolbox in Art Catalog here. And within that, I'll rename the toolbox Wildlife Data Migration. And within this toolbox, I'll add a new spatial ETL tool. Now this will open up the FME workspace. And here's where I can define my readers and my writers, what's being read in. So I'm going to read in my Excel file. But first, I'd just like to show you all the different formats here that we can read in. All these different file formats, all these Esri files, GML files, JSON. I can read in databases, and then I can write to all those same file formats as well. Now I'll go and I'll look at the parameters of my reader, and automatically it's reading in those latitude, longitude fields as X and Y coordinates, which is great. Right now I have this set up to write to an Excel file, but we're gonna write to an Esri shape file. We're gonna display this data on a map. I'll save it to my 570 folder. Once I hit OK here, it'll open up the FME workspace. And automatically it's going to be reading in my tabular data as XY coordinates, and it's going to be filtering where it can create point geometry and where it cannot. So this is automatic. And instead of writing here, I'm going to set up an error log. So I'll add a writer, and this will just be an Excel file rather than a shape file, and I'll call it error log. And we'll read in the schema automatically. So whatever source schema comes in, it will capture in the destination. So any records that do not have point geometry will get dumped in this error log. You'll see that my shapefile for the points is reading in the same exact schema as my source, which is great, but I can define this either automatically or manually. We'll set it to automatic for now. Now I want to join this up with my notes Excel file. So I'm going to add in that Excel file as another reader here. So I'll reference my wildlife notes. Check out the parameters, and it's reading in all my data as expected. And here's where I could change up the schema if I wanted to, but I'll leave it as is. You'll see there it's displaying my columns. Now I'll reference the transformer gallery here at the bottom left, and you'll see all these different transformers that I can use. Hundreds of them. But I know that I want the feature merger transformer to join these two data sets. Now alternatively, I know I could use the inline querier and use SQL code to join these up. But the feature merger is a little easier. And just in case I didn't know SQL code, I could use this transformer instead. So my notes file will be requesting the spatial data from my coordinates file. So I'll reference that as the requester, and I'll reference my coordinates tabular data as the supplier. And these two data sets are going to be joined up. Now where they're merged, and where they join, we want that to get pushed out to my geometry filter. And you'll see the schemas being automatically read in here in my destination file. I noticed that artifact type field name is a little weird, so I'll go in and I'll fix that. But first, let's set up the feature merger. And we want any not merged features to get kicked out to my error log so I'm aware of them. So we're going to go in and we're going to define the join between these two tables. And we're going to join them on object ID. I know that's related between the two. And we want the attributes and the geometry from my coordinate file. So that all looks good. The last thing here is to correct this issue with my destination schema. You'll notice artifact type isn't going over because I have artifact tie in my destination file. So we'll go in and we'll define that. We'll try to fix that. For some reason I couldn't fix it here. I have a feeling it's an issue with the shapefile. I don't know why it doesn't want to accept that field name. But for simplicity's sake, we'll just take the type out. We'll just have artifacts and animals as columns in my final destination. So now once I do this, it's not going to automatically know which source field to migrate, so I'll define that myself. Animal type will go to animal, and artifact type will go to artifact. Everything looks great here. So I'll save my workspace just in case I need to return to it. Then once I do that, I can run this, and it'll show you counts of records as they move. So we have 25 records being read in from each of my tabular Excel files, 25 features getting spit out to my destination file. Now if I look at my destination file in catalog, I see my shape file, and I can preview this, and you'll see my points on a map. That's great. And then I can open up the attribute table, look at all the attributes joined up. All those data values, looks beautiful. And I can dump this in an ArcMap session and actually look at these points on a map. So I'll go ahead and do that. I'll ignore that error for now. And if I look at the attribute data, what's in the attribute table, I can actually visualize different pieces of my data. So I'll just sort here by animal type, and I'll just select all of my deer. And now I could perform some kind of analysis on the deer, and I could check out perhaps, when it is that I'm seeing deer. I could look at the elk, perhaps find some similarities between all these different data types. I could run any kind of analysis I want. So that's great. Now we'll move on. We'll say I want to create a geodatabase with all of this data. So we'll go ahead and do that next. We're gonna add two different data sets, one for my artifacts and one for my animals. So we want those two data types to be housed in separate data sets. So you see here where artifacts is null, we have animals, and where animals is null, we have artifacts. So we're going to split those out and display these in this map document. So we're going to create a new Spatial ETL tool, and we'll read in the shapefile that I just created, but we want to create an Esri geodatabase and separate these two data sets. So automatically it's reading in my shapefile and it's writing to a feature class in my geodatabase. We can copy this feature class out since we want both animals and artifacts. And we'll rename these feature classes appropriately. So here we'll have the artifacts stored, and here we'll store the animals. Now to split these apart, I know I can use a transformer called a test filter. I could also use SQL, but this is easy and I don't have to write any code. So we'll go ahead and join that up and enter some test conditions here. So now we know that where animals is either null, empty, or missing, that we have artifact records. So for our output port, we'll specify artifacts. We'll hit OK. And we'll do the same for artifacts. For animals, sorry. So where artifacts is null, empty, or missing, these will be our animal records. So we'll go ahead and specify those parameters, and the output port will be animals. Now we also have anything else that isn't filtered getting spit out to that unfiltered port. So what we can do is we'll join up the artifacts to artifacts and animals to animals. And you'll see the schema being read in here. But we know that with artifacts, the animals column will be null. So we can just go ahead, we'll remove that data field altogether. And we'll do the same for animals. We know that the artifacts field will be completely null. So we don't need to bring that data field across. Now what I'll do with this unfiltered port is add another error log, just so I can visualize any errors that occur. I can also visualize that in the translation log down below when I run this ETL process. But this gives me a hard file that I can look at to reference any errors. So now the last thing I want to do, I know I collected all this coordinate data in a specific coordinate system that was unprojected. And I collected it in WGS84, but to display it on a map, let's say that I want to reproject it. And I know that the zone that this data was collected in is in 13. So we'll specify the source coordinate system as WGS84 unprojected, and we'll specify the destination as zone 13N. So we'll reproject this data on the fly here. And we're all set up, we're ready to go. So I can go ahead and save this and run this. And we'll see the data move across again. And we'll see the data split up by type. So we have 2 artifacts and 23 animal records that are split apart. If we refresh my folder over here, we'll see my geodatabase was created with the animals and artifacts feature class, with the attribute tables in there as well. So we can go ahead and display this on a map in my ArcMap session. First, I'll drag over my artifacts. We'll see where those are sitting, and just to look at where they are, we'll add some aerial imagery here. And once we do that, it's a little hard to see the points. So we'll go in and let it load. And we'll change what these points look like. We'll change the artifacts to green squares. Let's go ahead and dump in my animals feature class that I created as well. It's a little hard to see those, so I'll display those as well as something else. Maybe let's go with a lightning bolt. We'll make it a red lightning bolt. So now I can visualize my data and perform any kind of spatial analysis on it from here. So now the last demo that I want to show you is just, we'll go back to that shape file that we created and say we want to break it up by month here. You'll notice the month column. So let's split this data up by month, and I'll show you FME as an easy way to do that. We'll create another spatial ETL tool. We'll read in my shape file, but we just want to look at the tabular data at this point. So we'll split up the data by month into separate Excel files in my 570 folder. We'll call it wildlife by month. We'll hit OK here, and it'll open up our FME workspace once again. You'll see here my shape file on the left and my Excel file on the right. I can go in and specify in my Excel file. I can change the tab name in the Excel file. But instead of doing that, we can choose fan out by attribute, and it'll create a tab with the name of each month. Now to further fan this out, we can specify a file fan out over here. and we'll fan out the data set by month. So there will be an Excel file for each month. It'll be prefixed like that, wildlife by month. It'll include the month in that file name, and there's the suffix XLSX. So now we can just go ahead and save this and run this. I apologize, I'm going over my time here. We're at 20 minutes. But this functionality is too great to show you. And you'll see there are Excel files displayed in the translation log, and then we can open up the Excel files and look at the data by month if we wanted to. Now finally, I just gotta finish by giving SafeSoftware an A+, and also mention that they have the best customer service. I've gone on their website. They have live chat during business hours, Q&A forum with folks that are as responsive as any Stack Exchange forum, free live webinars, free FME desktop trial, free online training, and the most responsive team. I downloaded FME desktop, the trial, and I didn't activate it for a couple days, and they actually reached out to me to see why I didn't activate it and were asking me if I needed any help. Other products that they have FME desktop, but they also have FME server and FME cloud for maximum automation. And finally, I just want to mention that they go on their world tour every year. They go around the world and have daily stops. The stop for Denver is on April 13th, so it's coming up here. And it's really cheap compared to most conferences. It's only $25 to sit in on the world tour and to see what people are doing with FME. And I just want to close here and say thank you, and check out Safe's website. Reach out to me with any questions. I'd be happy to answer them. So thank you for listening. Take care.